Hello my dear students, if you are finding moment of inertia of a solid cylinder, okay, so the moment of inertia of solid cylinder about its axis, then it is mr square by 2, Why? Because moment of inertia does not depend on any dimension which is parallel to the axis of rotation. This moment of inertia of solid cylinder will not depend on L, on its length, not depend on the length, okay, only depend on the R, dimension which is perpendicular to the axis of rotation. Okay, if we are decreasing the length of this solid cylinder and making a disc, then moment of inertia will remain same, it is moment of inertia of disc mr square by 2. Okay, but what we have to do to find the moment of inertia about any axis, okay, which is perpendicular to the axis, of this solid cylinder and passing through the center. This cylinder is rotating like that. What will happen? How we can find the moment of inertia? Let's see. So to find the moment of inertia, what we have to consider? We have to consider some differential disk. So let us consider a differential disk. It is a differential disk. Okay, a differential disk, okay, of thickness dx and at distance x from the center. Okay, what we are doing here? Moment of inertia of solid cylinder about axis perpendicular to its axis, perpendicular to the axis of cylinder. This horizontal is the axis, horizontal axis is the axis of cylinder, and we are finding the moment of inertia about this perpendicular axis, okay, about this vertical axis. So what we are doing? We are considering a differential disk. So consider differential disk of thickness dx, at distance x, So what is the moment of inertia of this differential disk about this axis? So we have to use, it is our differential disk and we want to find the moment of inertia about the axis which is at x distance from its center. So what is the moment of inertia Ig of this disk about its diameter? Okay, first we have to find the moment of inertia about its diameter, and we can use now parallel axis theorem. We will use parallel axis theorem. So it is dm r square by 4. What is dm? It is the differential mass. Differential mass dm of disk. Okay, so Ig is equal to dm r square by 4. It is the moment of inertia of disk about its diameter. To understand this concept, you have to see previous lecture of perpendicular axis theorem, application of perpendicular axis theorem. So it is dm r square by 4. Okay, dm r square by 4. Now moment of inertia about this, let us consider it is di, differential moment of inertia. It is the dm r square by 4 plus dm x square. Here I am using parallel axis theorem. Parallel axis theorem. So it is the differential moment of inertia. Okay, differential, this portion we can. So differential moment of inertia, differential moment of inertia of disk di is equal to dm r raised to power 2 divided by 4 plus dm x square. Now what is the differential mass? How we can find the differential mass? So to find the differential mass, it is the total mass divided by total volume, which is pi r square into length L into differential volume of disk. So what is differential volume of disk? Its area pi r square into its thickness dx. Because mass is distributed over the volume in this case. We are talking about the solid cylinder. That is why we have to find the volume density, then differential volume, multiplication by differential volume. So dm, differential mass, is equal to m into dx by L. Now I am putting value of dm. We are getting r square by 4 plus x square in the bracket capital M dx by L. Now we can integrate. So the total moment of inertia, m constant, L constant, and integration of r square by 4 plus x square with respect to x. Now what should be the limit of integration? We have to move this differential disk from this L by 2, negative L by 2 to plus L by 2, from this point to this point, one end to other end. So with respect to the center of mass, this first end is minus L by 2 at minus L by 2, and second end, this end is plus L by 2. So minus L by 2 to plus L by 2. So I is equal to m by L. What is the integration of r square? It is constant, r square by 4 into x, and x square having integration x raised to power 3 by 3. Now I am putting value of L by 2 to L by 2. What we can do? We can multiply by 2 and change the limit from 0 to 2, because it is even function. Okay, we can use a property of definite integration. Okay, so we can multiply here by 2 and can change limit from 0 to L. What we can do? We can multiply 2 and change the limit from 0 to L of r square by 4 plus x square into dx. It is an even function. How you can find? By putting minus x at the place of x. Okay, we are getting same result. Minus x square is equal to x square. So it is an even function. Okay. So I is equal to 2 capital M by L. I am putting upper limit. So r square by 4 into L by 2 into L by 2 plus L cube divided by 3 into 8. Okay, we can take L as common. So we will get I is equal to 2 capital M by L. Okay, so we can take L by 2 as common. So L by 2, we will get r square by 4 plus L square by 12. So this L and 2 will cancel out, and finally we are getting m into r square by 4 plus L square by 12. This whole integration you have to solve once again by your own. Okay, so you can understand all the concept, and if you are facing any problem, again see the complete video, again watch the complete video. Okay, definitely you will understand all the concept. So it is very easy. Thank you very much.